Welcome back. Got my coffee. Let's continue on. So, anyways, when we change, this is not updating. So that's a bit of a surprise. Let's go into the code and see what I'm doing wrong. What I think I'd like to do for starters is when we generate this week against list, I want to see that list in the console log. So a way to do that is using debug.log. Debug.log, and this takes two parameters. One is, and this is really common for me to do, I just like to take whatever I'm doing, so please report that, and also please give us that list. Now of course it complains because it's like, oh hey, what do you want to do with the variable? You know, everything returns something when you do functions, so we're just going to say you can just assign that to a variable that we're going to ignore. Cool. Okay, so let's build that, and let's go back to our page, and let's do a reload, and let's bring up the development tools. There we go. There's our statement right there. We are weak against ice, dragon, and fairy, and it looks like our randomization worked because it picked one at random. It did dragon. Now I'll click something else, and I'm not getting more messages. So it's only doing this once, not every time we click. That's a good hint. So let's go back to Visual Studio. Okay, yes. So small mistake on my part. Just refresh your memory. So this is when we randomize the order of the opponents. This only gets called once. It's like, oh, we've randomized the order of the opponents. This is what gets called, I think, every time we do a counter. So this is probably where I should have put this weak against stuff. Yes, I think that's right. Okay, so here's what we're going to do. Let's move this statement over here. And also, let's move this over here. Excellent. And we can even move this over here. And I can grab this command none and just put that over here. Cool. Let's highlight everything and just do the old format document so that things are nice and pretty and lined up. Yeah. It sure didn't do a nice job lining up this. Well, no, I guess it makes sense. It does like to do everything in two lines, but it just looks kind of weird when it's two lines like that. That's all good. So, I think that's right. I think, yeah, so once you click counter, it calls counter with and does this, and then it does, yeah, that should do it. Let's try that. Let's go reload our page. And now, oh, that's interesting. Oh, the first one. Okay, we're getting closer. We're getting closer. Oh, of course. So initially, initially, so obviously as we go from counter to counter, we need to update this, but we also need to do it initially, and that was our problem. So if I just reload this page, it's like, oh, why isn't it set? Well, of course, because we haven't done a counter yet. Okay, well we can figure that one out. Let's go back to our code. And basically, actually we could do this in both of these. I don't mind that at all. Yeah. But I don't like repeating myself. So, I wonder if I should maybe have a function that will do some of this for me. Yeah, let's grab this, right? And I'm going to start a new function. What are we going to call it? Let's call it start week against selection, right? And what's it going to do? It's going to return a command. And right. Actually, start week against selection. And it'll need to know the opponent. The opponent PokeType. Ah, that's right, this is the type. And I got my colon in the wrong spot. And what we're saying is, given a PokeType, return a command. Okay. Not too bad. Now, we're going to do our let stuff again here. We're going to say let. There's going to be an in here. And let's grab this right here. I think this will make sense in a moment. So in order to generate this command, I do need to know that week against list. And lastly, okay, so there's the, let's just call it opponent. Generate. Ah, look at that. It's complete. Oh, again, lowercase message. Now it's highly typed. Yeah. Now it's typed. Okay. So since I got everything wrapped up nicely in one function, that makes it easier to write this. So we don't need this anymore. And we can just do this. Right, so we're starting the week against selection. Good. And so this is going to happen after a counter with, but it's also going to happen after we've randomized the opponent list. And I think that should cover us. So let's do a build. I'm still not sure if that's the best way to do this, but it doesn't seem too offensive, so I'm going to go with it. Let's reload this page. Did we build? I think, yeah, we built it. Start. Okay, great. So right at the get-go, there's a counter. It's called fairy. It should be weak against this. Normal is weak against fighting. Dark is weak against fighting. Fire is weak against water. Okay, awesome. Great. Okay. All right. Oh, once again, I'm going to wrap it up, and then we're going to work on our strong against and our normal against, which shouldn't be too shocking. So thank you. Hope you join me in the next one. Welcome back. Okay. So we've got our weak opponent here. Now we need to do the strong and the neutral. Shouldn't be too hard. Once again, just like we did before, let me just grab our mock-up. So in our mock-up, you know, we had we had gone to that PokeType table and we said, oh, if it's grass, then these are the things that it's weak against. So we want to do something similar with strong against. However, I also wanted to add kind of a reason why. I wanted to add some text. So I'm just going to scroll up and show you what I came up with. So I've got this function called list strong against and why. And in here, I've added kind of a description of why this is strong against this other thing. So for example, grass soaks up water. It grows over ground and it covers rock. So those are reasons why grass is considered strong against water, ground, and rock. Now I just made these up. I wanted to come up with something to kind of remind me why one thing would be stronger than the other. Rock is impervious to fire. And the best thing I could say for ice, flying, and bug is, well, it smashes those. So where I can, I've come up with kind of a reason why something is stronger than something else. And thinking it through, I realized I really only needed to do one direction. I need to describe why something is stronger than something else. If something's weaker, that's kind of the inverse. So this isn't something we're going to use in this step, but I did want to just put it in the data. However, for this step, we just want the list. We just want grass. Well, what's it strong against? It's strong against water, ground, and rock. So I've got another function up here that just, calls this one. So if someone wants to list the strong against, they can just, give me the PokeType, and we call this thing, we call our new function, and we only pull out, the strong against. So, so this returns a list of tuples. And this just basically says, okay, just convert that by using the list map operation. And I'm only interested, I don't want a list of tuples. I just want a list of PokeTypes. And that's exactly what this operation does. So let's grab these two things. Actually, before we do it, last thing, let's also talk about neutral. So things that are neutral are things that are not in the strong against or the weak against. So that's another thing in here. Let's just take a look. I think that's just up here. And it is. Great. So in addition to be able to listing strong against, you're also able to list what you're neutral against. And how we do that, if we just read this, it's like, oh, it'll make sense. So I create a list of all weak and strong against. So tell me what I'm weak and strong against. So that consists of basically generate the weak against list and then concatenate that to the strong against list. So this will be a list of everything that I'm both weak against and strong against. Great. Then to generate the list of what I'm neutral against, I can just say, okay, let's take that list of all things and just only report the ones that's not in my weak against or strong against. So that's what this is. Right, so list filter operation, only get me the ones that I'm not weak against or strong. Yeah, notice the not operation. Get me the ones that I'm not weak against or strong against. And that's how we get our neutral against. So I'm going to grab these, and that should let us practically finish off this thing. Cool. So that's in my clipboard, and I'm going to bring this into our code, PokeType. So let's bring those operations across. Boom. Okay, nice. So now I got my list neutral against and list strong against, and why, and the list strong against. Okay, let's make use of that. So going back here, here's the command that we use to start the weak against selection. I think I'd like to do the same for the strong against and the neutral against. So I'm actually going to duplicate this once and twice. Nice. And I'm going to change, I'm going to search for the word weak. And I'm going to change it to neutral. And we're going to make this case sensitive. And I'm just going to do, so I'm right here at the moment. I'm just going to do these four for starters. 1, 2, 3, 4. So there's one. And then I'm going to do the same thing here. Fine. This is just me being lazy. And we're going to say strong. And we're going to replace 4. 1, 2, 3, 4. Okay, and now I think I've also got some start strong against. Let's also change this one, so the lowercase weak. So anything that said weak becomes strong. So once again, looks like I got 1, 2. So I got to replace these two. 1. Oops, meant to start here. Come on. Let's replace this one. Good. So I've replaced these two. Now this weak becomes neutral. So neutral. 1, 2. Okay. Now I don't know if you caught what I did. Basically, we copied this and we just changed the word weak to strong, and then we also changed the word weak to neutral down here. Nice. And in the process, now it looks like list neutral against. I wonder if I spelt that wrong, because there should be something called list neutral against. Yeah, I think I spelled it wrong. Let's just be consistent. Ha! Here's the spelling error. Nice. Elm's got our back again. Sweet. Now we've got 2 messages that we need to add. So let's go over to message, MSG. And once again, it's going to be just like the week, except this time strong and neutral. Okay. Now it's going to be just like this. So the randomize strong against. Actually, we're going to have to fix these up, because right now they're just copy-paste operations. They're doing slightly the wrong thing, but we're going to fix that in a moment. Okay, so no compilation failures that we can see at least. But we are doing the wrong thing. So this is the right thing for a weak against. So let's see. So this gets called after we randomize the strong against. We get a PokeType back and maybe PokeType, and we just need to change this right here. So strong against, and this will be weak against. Sorry, neutral against. Nice. So after we've got the randomized weak against, then we can do the strong and then the neutral. So let's just add that in. So start the strong against selection. That's what we're going to do. So we start with a weak. Then we can, hey, come on. Start the strong against selection. And of course we need to know what the model opponent is. And once we've done the strong against, we can do the neutral against. Yeah, that looks pretty good. Now that we've got the strong, now that we got those done, let's do this. Start. Let's see. Opponent randomization. Yeah. Not opponent, counter randomization. In fact, you know what? I'm just going to put it right here. Let me think for a moment. Oh, you know what? Maybe we'll do that as the next step. How does this sound? Here's what I think we're going to do. So this was always a bit of a hack. This was just so we could see the PokeType, right? We don't actually need that, so I'm going to get rid of that. So all we do is first we randomize the weak. First we pick the randomized weak against, right? Then we do the randomized strong against. And once again, we don't need this counter. But then, as a kind of a final step, and this is only temporary, is I will just say counter width is going to be, we're going to go back to the model. So we'll put the neutral one in the middle, and then we'll put a strong against one here. Model. Strong against, there we go. And over here we'll put model weak against. Okay, so this is just temporary. We're just saying, hey, when we're done this step, and we can just stop we can do CMD none here. We can just do this. Yeah, okay, so I'm going to do that for now just so we can test it. In the next step, we're going to randomize the counters. So at the moment, we're going to have a strong against on one side, neutral in the middle, and a weak against on the other side. So let's see if that works. Let's build it. Compiles, ship it. Let's reload the page. And we don't think we need this. Let's go start. Nice. So fire is strong against ice, neutral against ghost, and weak against water. So yeah, you can pick any. Right now we're not doing anything with the counters, so we can just see that. Yeah, seems to be doing the right thing. Okay, so let's take a little break, and then we're going to come back and we're going to randomize these. So at the moment, I don't know if you caught this. Let's see. So yeah, rock. Let's do one. Oh, hey, and then there's normal. Error. This should not be used here. Okay, so normal, if we took a look at that list, I'm kind of glad this came up. Normal is not strong against anything. So we kind of have that little catch-22. And we'll fix that one up too. Okay, let's keep going though. Yeah, so always the one in the middle is neutral, and the one on one side is one strong, one's weak. That's what it comes down to. So we do have that. Now we want to randomize the order, and we also want to start updating the score depending on if they chose the right counter. Okay, so thank you, and I'll see you in the next one. Welcome back. Okay, so I've been thinking about this situation here where we have this normal and we have this error, internal error, because we don't have, normal's got nothing that it's good against. You know, when we look at that list, it's weak against fighting, but it's not strong against anything. So our current logic, and if we jump back to our logic, we should see it pretty easily. Let's go back to Visual Studio Code. Where is it? That's over here. And there it is. When we randomize stuff, if we, you know, basically we go through the list, and if we, this is our fallback, we use the should never occur. So I think what we're going to do is change this. So this shouldn't be should never occur. Instead, it should just probably be ourself. So yeah, because we don't really have anything we can stick in here. So if we just put ourselves in here, so if I say instead of this, it's just be another normal. Of course, if you click on this, you'll get no points, but we don't have anything that gives you points. So for normal, you'll have to know, oh, pick fighting, right? So let's go back to the code and make that change. So instead of should never occur, we'll go to the model. Oops. And we can do this for all three cases. If you can't find a match, if there is nothing in that array, then just go model.opponent. And that's a much better choice than the should never occur. We'll do that here. And we'll do it here. Nice. Let's compile that. And then go back here and do a refresh. Reload page. And let's click until we see normal. So I'm expecting when we see normal, we'll see normal over here. Keep going. And we do. Yay. And hey, I don't know if you noticed that when we hit dragon both on here and here. And that makes sense because dragon is both weak against dragon and strong against dragon. It's kind of a funny one that way. So there is the possibility that you could see those two. And we'll take that into consideration when we compute the score. Because basically it's like, if dragon versus dragon, kind of equal. Okay, so I think we should save this change. And as always, I have been saving these changes. So let's just go back to code. Visual Studio Code, and I'll just say fix the logic for normal type. And we'll commit that, and we'll push it up. Okay, so far so good. In the next step, I think we're going to do some score logic. So hope you join me in the next one. Thanks. Welcome back. Okay. Let's start updating the score. So why don't we start by jumping into the code, and let's write a function that, given the opponent type and what I counter with, will figure out what the score change should be. So let's write that up. So let's see. Get score delta. So how does the score change? And this function will take a PokeType and another PokeType and should return us some kind of a score change. So it'll be an int. So far so good. Let's give it a body. So let's call this the opponent type. Okay, so that's our opponent, and let's call the next parameter my counter type. Okay. And now just for starters, we'll say it's 0. Okay, we're going to fix that in just a minute. Now, how are we going to use this? Well, when someone clicks on I'm countering with this, that's when we're going to compute what the score delta is. So why don't we just do it right here? In fact, as a test, I'm going to say, let's just 5. That sounds good. just so we can see it working. So what we're going to do is we're going to say score delta is equal to get score delta. Now we need to tell it what the opponent is, and now this would be the existing opponent, not the new one. So he just selected his counter. Because he selected his counter, we're about to select a new opponent. So I'm going to do this step up here, I think. So we'll do this first. We'll say model.opponent, that's the opponent, and what did I just get counter? What did I counter with? Well, it's whatever PokeType I passed in here. So that looks good. We know what our score delta is. How will we use score delta? Well, when we update the model, we're going to say that in addition to updating the opponent, see, let's multi-line this now. It's starting to get a little complicated. Oops. Let's do this on a new line. We're going to also say that the score is equal to model.score plus the score delta. Let's highlight everything, give it a format, compile, and try that out. So at the moment, because we hard-coded the 5, I'm expecting that every time we click on something, our score should go up by 5. So let's reload the page. And our score is indeed updating by 5. Nice. Okay, now let's flip back and add some real logic. So go back to code. Let's look for that score delta. I know it's around here somewhere. Get score delta. There we go. So to do the score delta, we need to know if we are weak against, if our counter is weak against or is strong against our opponent. So we've got the logic to do that, I think. Yeah, we do. We have those lists, so we can just see if we're in that list or not. So let's do some nice let statements here. So I'm going to say let, and I'm going to say is counter strong, and that's going to be equal to, okay, so now we're going to check. We're going to check. I'm going to list.member, so that finds out if we are a member. I'm going to say, is my counter type a member of, and we're going to list the strong against for the opponent. Opponent type. Let's just grab that. Better copy pasting than typing. You probably noticed that. Okay, and then we want to do the same thing. Actually, why is it? Oh, it's because we're not complete yet. So let's just keep typing along. So first we're going to see if it's strong. Then we're also going to see, is it weak? Is counter weak? And list weak against. Okay, so far so good. Great, so we know if it's strong against, we know if it's weak against, so now it should be pretty simple to compute the delta. So we'll say in. Now we do have 4 combinations to do. We could do if, we could do like a couple of nested ifs to come up with a number, but I kind of like this. I like doing a case expression. So let's do case, case, and then we're going to say is counter strong, comma, is counter weak of. Nice. So we're passing in a tuple of 2 booleans. So in one case, it might be true and true. So if it's both weak and strong, then what we want to return is no change in the score. I think that makes sense. Otherwise, so now Elm's got her back. It's like, hey, you haven't got everything listed. So let's just list every possibility. So true, true will be 0. So will false, false. Right? And then what about true, false? And false, true. Let's see. If our counter is strong against, I think that's minus 10. I go for minus, and this will be plus. I could have these the wrong way around. Let's just try it out and see if it's right. Yeah, that looks right. Okay. Is Elm going to complain? I don't think so. Nope. So now we can reload our page. Try it. Now, this is always strong. Let's see. Poison. Let's go to one we know. Rock. We know water erodes rock. Good. Okay, that's right. So this is weak. Yeah. This is what we want. So we're flying versus fighting. Yes. Give me 10 points. Fighting versus dark. Give me my 10 points. Rock versus ice, give me my 10 points. So this is the one at the moment that defeats. Now, for Ghost, however, Ghost, it's both weak against it and strong against it. So that should be a 0. So let's see if that's what happens. And it was. The score didn't update. Good. For normal, well, let's keep building our score up. Fighting beats normal. That's 10 points. However, rock gets covered by grass. So if I do this, I'm expecting the score to go down 10 points, and it does. Now let's try some of our neutrals. So all of these neutrals should not change the score. And that's working. So I think we've got our score updating correctly. Superb. Okay. Woohoo, it's almost a game now. All right, hope to see you in the next step. Thank you. Welcome back. Okay, so now we want to randomize the 3 tiles that go on the bottom. At the moment, basically we have a loser, and then a non, then a, nothing, then the winner. So if we continue, click on this, our score will just go up, 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 up. But what we want to do is we want to make this random so that the user has to think about what's better, what defeats ground. Oh yeah, it's water. What defeats electric? Oh, I think it's water. So we would like this to be randomized. Now, previously when we did random stuff like this, we would pass a list of, we passed our list of opponents, for example, into a randomizer and just said shuffle it. Just shuffle it. But in this case, the way I've represented this data is actually a tuple. There's a tuple of 3 Pokemon. So let's go back to the code for a second. We'll see that. So here's the code. And here, somewhere in here, we have the, oh, here it is right here. The left counter, the center counter, the right counter. So in the model, we've got something called counter width. And it's a tuple that consists of 3 Poketypes. And that's kind of important because we know that we want 3 all the time. And the fact that they're all the same thing, it's a tuple of 3 things, that just kind of worked for me. So I prefer to use a tuple rather than an array. I could have used, I'm in a list. We could have made this a list. That would have been a valid design decision. But for me, it felt appropriate to use a tuple because I knew that we'd always have, 3 available. But that does cause a small problem for the randomness. There is no, as far as I know, there's no easy call to say, please take this tuple and randomize the elements inside. It just doesn't make sense. But we do know this. We do know that there's only 6 different ways you could do it. There's only 6 different ways we could arrange that stuff. So here's what I'm going to do. Like when we think about strong, weak, neutral, there's only 6 different ways this could be done. Hey, if I got it wrong, we'll go back and we'll change the number, but I'm pretty sure it's 6. So if we generate a random number between 1 and 6, then we could rearrange the tuple appropriately. Okay, that works for me. So let's go back to the code. Let's go back to the code. Here we go. And currently, what actually assigns that counter width? Actually, let's just search for counter width. Counter width. Here it is. So currently, when we get to the randomize neutral against, the next step is, oh, by the way, and this was one of our shortcuts. We just kind of did this so that we'd see something on the screen. But obviously what we want to do is basically another, we want to generate the counter width. So what do we want to do? I think we want to randomize the opponent order. Yeah. Okay, so that's what we want to do. Let's maybe do this. Let's generate a command for randomizing the opponent order. And it's going to be a little easier than this, so start opponent, so we can start the opponent order selection. Now, we don't need to know the PokeType. This will just return a command for us. Cool. But I guess we do need to know the model. So maybe I'll say actually start opponent order selection. Let's say give me a model and we can do it. Given the model, we can return a command that has randomized the opponent order. Okay. So model goes in here. Right. So what are we going to do? Well, first of all, the message is going to be generated. It's not going to be randomized weak against. It's going to be randomized opponent order. And yeah, for this we need to generate a random number, a random int between 1 and 6. It could be 0 and 5, depends on how you do it. But in this case, we'll just go for random dot int something between 1 and 6. Cool. So we'll get a message back called randomized opponent order when this is all done. And let's actually, before I do this, let's just stick this in here. So here's the idea. After this last step, previously in this last step, we updated the counter width, right? Well, we're going to get rid of that code. And instead, we are going to say, hey, after this step, please start the opponent order selection. So that'll kick off this randomization operation, and it'll come back with a number between 1 and 6. So let's go to our messages. I know you're in here somewhere. Find message. And now we know that there's another message that we need to support. And this one will be parameterized by int. So we know that it's supposed to return an int. Now I'm surprised I don't see red. Oh, there it is. Yes. I was expecting to see this. I was expecting to see it complain because we haven't actually said what to do if randomized opponent order comes back. So that's what we need to add. So randomized opponent order. Randomized opponent order will give us an order. I'll say order int. And now we can do a big switch statement. So case order int of, and we can start with 1. So if a 1 comes back, what are we going to do? We're going to return, so here's what I'd like this to do is, let's see, we want to update, oh, that's right. I think I'm going to put this in a let statement. So, what am I thinking here? Sorry, guys. Let. So, I'm going to do a switch statement here where I'm going to get back the different things that we could counter with. And then we'll set that in our model. So, I'm going to say, counter with equals case and order int. You know, I'd rather call that random int. So this is random int. Actually, I know it's random int. I'm going to call it random. Do I want to? Nah, don't really need to do it. I'm thinking about calling it something that says this is between 1 and 6. Why not? 1 to 6. Random int 1 to 6. That works for me. Case. So in here, now, of course, there's no way that the system can know that it's between 1 and 6. We know when we said please generate, it's going to be one of those numbers. So one of them is going to have to be the special underscore, which should never occur. So let's do our 6 cases, and then let's add something to occur if something goes wrong. So this makes sense to me. So it might be a 1, and if it's a 1, let's do this. Let's return a tuple that consists of model, and we'll say the strong against, the neutral against, and I'm just making this up, as long as we're unique here, and I'll say model dot weak against. Weak, oh, model dot weak against. Okay, so that's one of the 6 combinations. Let's do a second one, and I'm going to keep the first the same, strong against, and I'll just change the order of these last 2. So we'll say weak against goes here, and neutral against goes here. Ah. Cool, except that should be a 2. Now, if it's a 3, now let's start adding a couple where we start with neutral against. Then we'll put, let's say strong against here. And all I'm trying to do is have every permutation combination covered. I like to claim that my keyboard is not very good. That's why I have these typos. But really, I've just never been very good at typing. That's okay. It gives me time to think. 4. Neutral against. Okay, so now I got this. Yeah, I'm trying to do 2 of these, and then 2 of the other. So neutral against, and let's just change the order here. I think you can see the pattern. Boom. And finally, let's duplicate this one. 5. I've got a strong against, neutral against, and then let's do weak against first. For weak against, let's change this to neutral against. duplicate that, make this a 6, and now I need to put neutral here and strong here, and I think these are all the possible permutations and combinations that we can have. But the compiler won't be happy unless we say, what if it's another number? And if it's another number, well, this should never happen actually. So I'm going to say return should never occur, comma should never occur, comma should never occur. Nice. Okay. Oh, so sorry, this chooses our counter, so now we got to do something with all that. And we can say in. Now we can update our model. Once again, it's a tuple or tuple, depending on what you prefer. And we're going to update model. Model, and we know that we need to update the counter width, and we need to say counter width, the counter width that we just computed. That'll work for me. And the second part of this tuple is, or tuple, is the command to continue on with. And actually we're done here, I think. So when the randomized opponent order comes in, we get this and we update our counter width. That looks right. Okay. Now why is it complaining up here? Something is off with the 6th branch of the case statement. Actually, you know, the error messages in Elm are actually pretty darn fine. So, let's do this again. Oh, so let's see. Yeah, I've obviously made a bonehead error. This says it's supposed to be something that given a model returns a command, but the annotation on update says it should be this. Oh, yes. Okay. Get out of the way. I think this might be what's causing our problems. So start opponent order selection. Right, okay. Ah, I see the problem. I forgot about this. So this needs the model to be passed in, and I didn't pass in the model. I just said start opponent order selection, but we actually need the model to be passed in. Okay, that looks pretty good. Let's build this. Excellent. Let's go back to our page. Let's reload. Let's start. Okay, so now we should, some of the times this should be a winner, sometimes a loser, sometimes a medium. So let's see. 1, so that's a loser. I'm looking up here, by the way. That's neutral. That's a loser. That's neutral. Hey, now it's a winner. Same thing here. Should see the same kind of random thing here. Loser. Let's see. Winner. Neutral. Loser. Okay, same thing over here. Neutral. Winner. Keep going. There's a loser. Excellent. So these appear to be nicely randomized, and I never saw our special case should never occur. So let's just apply some logic here. Let's see if we can get our store up. Well, fighting will definitely be better than normal. So fighting defeats normal. I'm expecting it to be, I'm hoping green and say +10. So let's try fighting. Yes. Rock. I think steel crushes rock. Steel cuts rock? Let's find out. Steel crushes rock. Cool. Water. Ooh, let's see. Definitely not fire. I think it's electric. Electric flows through water. But let's try something we know is wrong. So I'm pretty sure, water puts out fire. So I'm going to say fire, and we should go down 10 points. And we do. Nice. Let's skip by this one. go to something I know. Steel. Let's see. Let's try electric. I'm looking for something that I can figure out. Okay, water definitely puts out fires. If I do this, it should go up 10. Fire is weak against steel, I think, but I think it's neutral against dragon. So I'm going to try dragon, and it is. So it just says fire versus dragon, and the score remained unchanged. Okay, this looks really good. So all we've done is we've randomized the order of the tiles here. You don't know what order is going to come in, and that gives you a working game. Wow, so we're pretty darn close to being done here. Coming up next, I think we'll maybe get our timer. I'm not sure, 30 seconds, that seems pretty short. Maybe for testing we'll leave it at 30, but we might want to extend it to like 60. You know, give the guy a minute to try to do as many as he can. And then when we're done, we'll try to maybe do a summary of here's your statistics so that I can try it again after that. Okay, so I hope you join me in the next one. Thank you very much. Welcome back. Okay, let's work on the logic to display a message after you've done, after you've selected your opponent. So for example, if I were to select, bug against rock, it should say something along the lines of rock crushes bug. I think that's right. Or yeah, something like that. So we've already got our logic for saying why one thing is stronger than the other. So let's start with that. Let's go to our application. Go back to code. Oh, and before I continue, I'll just check this in. So this last change is add score updating. And if you ever forget if you need the repo, it's always listed in your package JSON, I think. There it is. It was right there. Yes. Good. Okay, so let's go to Elm. Let's close them all. I get too many screens on the brain sometimes. Okay, so this is going to be a little complicated, but let's build from simple principles to harder things, okay? So the first thing I'd like to do is, I've got this in my mock-up, so I'll just grab this. I think the first function that we need is getting the strong against reason. So if I got two PokeTypes, this PokeType against this type, then I should be able to, if there's a reason why it's strong against, then I can return that string. So, as usual, let's do like a let statement and call this function here. Right, so we wrote this earlier. Remember, you can list strong against, but you can also list strong against and why. So this will return a tuple that shows not only what we're strong against, but why. Good. Now, what do we need to do next? I'm just looking at my example. Oh, well, let's filter it. So, first thing we do is for any PokeType, we say, hey, get a list of strong against and why, right? Then we filter it. It's like, hey, do I have this against type? So for this type, do I have something against it? So if I do, then I'll get something back. So one of two things is going to happen. We're either going to get something or we're not. So we're going to say case, right? Now this is a little interesting. Actually, before I go on, I wonder, this may not be the best way to do it. I did list.filter. I basically, you know, this is returning a list, right? And then here I do a filter. I'm looking for, is my against type listed in there? And if it is, I return it, okay? So what we're expecting back, you know, we're getting back a list. And if there is something in the list, then that's what we want. But if there's nothing in the list, then we return nothing. So that's what I'm going to try to do. There might be a better way to do this. I'm thinking now, maybe I should have done like a list.find if there's such a thing. You know, because I'm just interested in like the first match. Okay, well maybe that's something to think about, but this is how I did it when I thought about it a couple minutes ago. Okay, so let's do the, let's do the case statement. So this, what are we going to do with this? We're going to say list.head. So we know we got a list back, but it might be an empty list. So list.head, and this might return something or might not. So we do a case on this. So if we got something back, and what we're going to get back is a tuple of y and the PokeType. Okay, but what we want to return from this function is just the reason why, I think. Does it look right? Just, oh, and I need to say, this. We said this is a maybe string, so I'm going to say just y. Nice. That way, if we get nothing back, which would be very common actually, then we can just return nothing. Sweet. So now we've got a nice function. You give it two PokeTypes and it'll tell you if one is strong against the other. Cool. Now, let's try to use this to come up with a you know, a reason why one is stronger than the other. So let's build a unified string. You know, grass is strong against. Let's see. No, grass soaks up water. That's the kind of thing that we're trying to do. Is grass soaks up water. So let's build a function for that. That's going to use the strong against reason. So it's going to be very similar in the signature. It's going to be PokeType versus PokeType will be, and we'll always return a string for this one. Now, the reason why we can always return a string for this one is, and I'll call this one, what am I going to call? I'm going to say versus or y. The reason why we can always return a string is because if we don't find a reason why it's strong against or weak against, then we can just say versus. So, you know, if you got two things that are neutral against one another, we can just report, oh, versus this, and that's going to be like 0 points. So, let's write this one up. So, similar signature. Versus or y. Get these two types. And now we're going to call this thing twice. Now why are we calling it twice? Well, we're going to say, we're going to see if we're strong against, and then we're going to ask the reverse question, is the other one strong against us? And depending on what we get back, we can return, you know, something that makes sense. So let's do the old let statement here. Let, and we can do this. I can say strong against reason is equal to, excuse me, get strong against reason. And PokeType in the against type. Actually, I'm going to rename these. This is the, in this case, it's going to be the opponent type versus my counter type. And for this one, actually I'm just going to copy this over so we can see this. Boom, boom, boom. Right. Let me go in, and I'll just return an empty string for now. Okay, so here's the idea. The first we ask the question, hey, is my counter type against this opponent type, is it strong? Right? So that comes back with a strong against reason. Then we're going to ask the reverse question, is my opponent type strong against me? So that's the reverse one. And based on this, we can kind of do a case statement and return what's appropriate. So let's see. Let's do this. Let's go case strong against reason of. So this is going to be either we have a strong against reason or we don't. So if we have a strong against reason, then we can return a string like this. And I'm just going to copy my little prototype here. I mean, that's pretty easy, I think. So, excuse me. Yeah. If we have a reason why one is stronger than the other, then what we're going to do is we're going to return a string where we're going to get the name of the counter type, and we're going to add the reason, and then the opponent type over here. I think that's right. Okay. Otherwise, we need to take care of the nothing case. So let's just get our indentation a little nicer here. Nothing. Now let me just see if I go quote, quote. Yeah, no syntax errors. Good. So we got those cases covered. But actually, if there's nothing here, then what we want to do is a case statement on the reverse, strong against reason. By the way, we could have actually done a tuple thing here where we evaluate both, but this made more sense to me. First we check this one, and if we got something, say why. Otherwise, consider this case. So case, and this would be the reverse strong against reason of, okay, then we say just reason and if we have a reason, we can, it's going to be very similar. Actually, I'll grab the one that I already, actually, I'll just grab both of these that I already wrote and just bring them over. Nope, that didn't work. Hold on. That's a little better. So you can kind of see the pattern here. It's like, hey, were we strong against? If we were, then display, you know, my counter type, and then the reason why it's strong against this one. Otherwise, we do the reverse. Hey, if we got a reverse reason, then, you know, my opponent type versus this. Yeah. So that's good. Otherwise, it's just, well, whatever the counter type was versus the opponent type, we just say versus. I think that covers it. Excellent. Okay. Now, building up from this, the final thing is that ultimately, why did we write all this stuff? It's because we want to be able to update that last round summary, right? So let me just put this in here. So, and grab this one too. So, once we know the opponent type and what we countered with, we should be able to generate this last round summary. And as we can see, there's a message and a color and a score delta. So that's what we want to fill in, is what's the message, the color, and the score delta based on this opponent versus my counter. Cool. And rather than reinventing the wheel, I'm just going to, what the heck, this one's taking a while, so why don't I just copy paste the whole darn thing. And I think it will make a modicum of sense now that we've written the other stuff by hand. So let me look at this. Boom. Okay, so yeah, this isn't gonna, nothing shocking here. So here's how we compute it. So I know what my opponent is, I know what I'm trying to counter with. So naturally I need to know, is the counter strong? Is the counter weak? And based on that, we can do a switch statement for the colors. So I can say, you know, if it's weak and strong, well, that's yellow. That's, you know, it's in between, and then the score change is 0. If both are weak, then if it's not in either category, once again yellow and 0. If it's true false, that was bad, -10. If it's false true, then hey, that was good, give them +10. Then we need to, you know, we want a string about how the score changed. Okay, so that's what I'm trying to do here, the score delta display. So the thing that occurred to me is, if it's negative, you know, when I convert a negative number, I want to put a plus in front of the positive numbers, is basically what it comes down to. So if it's +10, I want an actual plus in front of it. So that's what this function's doing, is it's like, hey, if the score delta is, and you notice the score delta is actually computed here. It's 0, 0, -10, -10. By the way, now that we got this written, we're eventually going to be able to get rid of our other score logic, because it's kind of taken care of in here. So yeah, we'll update that one too. So there's the score delta. And finally, the message. So the message is going to be, you know, score delta display, right? So it's going to be something like, just what it says here, like +10, fire melts ice, right? So we're building up from our primitives. Ultimately, we're calling that versus or y. And did I call it that? I think I did. I hope I did. Yes, we're calling this thing here to return that string that's being displayed here. Okay. I think that's pretty good. Let's wire this up. So, at the moment, let's see. At the moment, someone's doing this get score delta. Yeah, we're doing the get score delta here. And we're not actually going to need that. Instead, what we're going to do is we're going to do something very similar. So that is score delta. We're going to generate last round summary. So let's do that. Last round summary equals, and it's going to be same calling parameters. Boom. I can get rid of this. And as far as the score updating, we can just grab the last round summary score delta. Nice. Okay. And lastly, the last round summary is going to be equal to, well, the last round summary that we just computed. Type mismatch. Oh, what did I do wrong? Let's just take a look at this thing here. Actually, so this is supposed to return a last round summary. Okay, that's going to be a guarantee. You give it a PokeType and a PokeType, it gives you a last round summary. And we just assign that to last round summary. Oh, here's why. This last round summary is actually, in the model, it's a maybe type. Maybe a last round summary. So it may be nothing, or it may be something. And in our case, it is something. So I can just say, just. Awesome. Now, lastly, if we look at the view code, I just want to point this out. We already had some stuff in here. Basically, it says, hey, if we do have a last round summary, then please display it. So let's give this a compile and see how it looks. Fingers crossed. I think it should work fine. We compile, we reload the page, and we start. So initially, the last round summary is nothing, and we see nothing. Now, let's say fighting. So I think fighting should, fighting should defeat normal. And it does. Plus 10, fighting beats up normal. Maybe that's politically incorrect. I apologize. But fighting beats up normal. And our score went up by 10. Let's do, now we've always got a good counter here. So every time I click on this tile, I should see our score go up by 10. Unless it's a tie. So rock should smash bug. Let's try that. Yeah, rock smashes bug. Great. Now let's try the opposite. So fairy should defeat dark. So I'm going to click here. Fairy always defeats dark. Hey, that's nice. And similarly, grass. So let's do another bad one. Grass should be killed by poison, I think. Poison kills grass. Okay, now let's do something neutral. Let's go dragon. So we should see fire versus dragon, or dragon versus fire. Yeah, we do. So no points awarded, fire versus dragon. Nice. So obviously this is going to be a very easy game to win at the moment. Click, 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 click. You know if we click this one, we always do the right thing, and this one's always the wrong thing, and this one's always the no change in score thing. That's okay, because we're going to fix that in the next step where we randomize the order of these. Anyways, hope you can join us again. Thank you. Welcome back. Okay, let's finish off the timer now. So at the moment, we've got this timer that starts at 30 seconds, and we want to count down. So I'm going to use, let's search for Elm delay. Delay. I'm going to use this third-party package by Mr. Andrew McMurray called Elm delay, and it does exactly what I want. Basically, you pass it, basically say, hey, wait for 500 milliseconds, and then we'll get a second message. Pretty easy. Let's copy this. Andrew McMurray, Elm delay, and we should be able to add that into our project. So go back to Visual Studio, and we'll do Elm install, paste that. Yes, please, give me that library, and now we've got that library installed. Excellent. Okay, next thing, we're in the right place too. After the user initiates the start, that's when we want to start the countdown. So let's do this. Let's say, let's do this. So we're going to need to, instead of doing command none, we're going to say delay after, and then after 1 second, we're going to send the message called next second. Okay, that works for me. We need to add that to our list of messages. Oh, I went too far, bugger. One more time, there it is. Next second. Okay, and as usual, we're being informed, hey, you've got a case you haven't handled yet, which I love. Actually, I'm going to put it near the start so we can kind of see these two things together. So let's say when next second happens, what do? Well, it's a tuple of the update the model, and we want to say model dot remaining seconds equals model remaining seconds minus 1. Oh, sorry, my mistake here. Don't need to say that. Excellent. So we're just saying, hey, whatever is currently in remaining seconds, subtract 1 from it, and that's the new settings for remaining seconds. And then the next thing is, well, what command do we do after this? And we could do command, well, we can do command none, but that doesn't make sense. What we're going to do is, if we haven't reached the end, we're going to trigger it again. So let's put an if statement here. If the remaining seconds, model remaining seconds, is greater than 0, then we're going to do the next delay. Else, we can do command none. And I'll maybe highlight everything and do a quick format. Format. So it gets nice and pretty again. Okay, let's compile the code. And now we can run it. So now I'm going to reload, and when I start the game, I've got a countdown. And now it's only a matter of time before my time runs out. So let's see. Water, that should transpire. Don't have a good counter here. I think steel's wrong. Yeah. Grass. Ice covers grass. Never a good choice for ghost. Ghost, yeah, kind of equal. Okay. Now, I noticed something here. We went too far. Time remaining goes to -1. And let's go back to the code. And let's go back to our next second. So let's search for next second. Okay, I'm looking at this, and I think what happens is this is evaluated before this is complete. I think it's basically, it's already evaluated this, I think. So what I'm going to do is I'm just going to say, you know what, actually 1 is the magic number, and if we do that, then I think everything works right. So by the time this should hit 0, and then this stuff should erase. Now this erases because actually there was some stuff that says, hey, if the time remaining is 0, don't display it. Let's see if we can get a couple in here. So what defeats dark? Psychic? No. What defeats psychic? Dark? Okay, that's a little better. Ice, ground. Nope, that wasn't right. Oh, I'm doing horrible. But at least I did horrible, and it hit 0, and I know that my score was -10. Wow, that was horrible. Obviously, I need to practice this. But that's pretty good. So it stopped at 0, it erased the bottom, and then we have an option to play again. And I think if we hit the play again, it's kind of going to work, but it may not reset the time. So let's see. Ah, yes. So when we hit play again, it did the start again, but it didn't reset the time remaining. So let's do one more quick change. Let's go back to code, and what do we want to do? Oh, I know what we should do. Whenever we start, we should probably reinitialize the time remaining. So I'm going to say remaining seconds is equal to, And what do we call it? Game duration? Yes. Okay. And I should probably also make sure that the score gets reset to 0. So score is 0. And those are the main things that I need to make sure are reset. Okay, let's build that again. Let's see if it's working a little better now. So I'm going to reload my page. We're going to start. Okay, what beats rock? Flying? Nope. Ice. Steel cracks ice. Yes. Ground beats electric. It insulates. Normal. Can always fight normal. And okay, 2 seconds remain. Boom. Okay, so score is 20. Time remaining 0. If we play again, the score should reset to 0 and time remaining should hit 30. Boom. Okay, that's looking pretty good. I think our next will maybe make the summary look a little better, but other than that, we're almost done. So, hope you join me in the next one. Thank you so much. Alright, welcome back. Okay, let's do one last thing. What I'd like to have happen is maybe have some kind of a highlight when the game's over and you've got your final score. So let's skip over to the code. And I think what I'd like to do here is just a simple animation. As a matter of fact, let's look at this again. So currently the score is just, you know, an H2 over here. I think I'll maybe, when it's the final score, when the time remaining is 0, I think maybe we'll transition to a box with a border around it. I know that's not too exciting, but a little animation there kind of says, hey, you're done. So let's give that a shot. That's about the best I can come up with. I'm not a game designer, that's for darn sure. So let's go back to our source. Here's our source. And I do kind of know what we want to do. Let's see, so here's our score, and it's just one of many divs listed under our title section. So that's kind of our top box. So let's just stick this. One thing about these divs is they go from end to end, and we want our stuff to be in the middle of that. So here's what I'm going to do. I'm going to wrap this in a div. So we'll say div, braces, braces. I'm going to grab this H2, and we're going to stick that in here. And we'll keep this center class here. And I think that should be the same as it is right now. So let's just see. Let's just do a reload. Okay, yeah, no change. Back to the source. Now, what I want to do is I want to dynamically change the class which is applied to this specific H2. In one case, I want it to be, I want to be able to say that it's a final score. In another case, not. Now, I've actually mocked this up. So let's go over to our CSS. And I'm going to bring in two classes. Score and final score. So score is kind of like, well, that's what we're seeing. It's the score. And we're going to say actually it's got a certain width and a height. You know what? I don't even need the width. I'm going to get rid of that. Yeah. I just want to say the score set. Oh, actually I do want the width. And the reason why I want the width is because I do want the box to be, you know, around it. Okay, I'm going to keep that. So let's apply the score section. Now you'll notice I don't currently have a border. So this is saying, hey, before we transition, this is how big the score section is. So let's just check this out. So let's go back to our, what did I do? Oh, goodness. Let's go back to here. And I'm going to say, hey, this is part of this is the score section. Now I'm going to build this real quick, and I think we'll see just a tiny bit. So now there's a bit of a margin in here. We're saying that this is 40 pixels, so let's just reload this. And it's ever so slightly different. It's about the same size. But what we're going to do is we're going to surround it in a border, and we're going to make the border, we're going to see the transition when we hit that 0. At least that's the plan. Let's go back to our source. And, ooh, that's not our source. Come on. Here it is. There we go. Let's try the, actually, just as a test, let's also add this class. So this is the final one. The difference is it starts off with a height of 40, and then it'll eventually be a height of 100, and it'll have a border turned on. So, you know, the score will always have this, and then this is what we're going to do when we see our final score. That works for me. Just as a test, we're going to do one more thing. We're going to actually just go back here, and let's just see what it looks like if I say score and final score. So we won't see the transition, but we should see what it looks like. So let's build this, reload our page, and now that's what the final score looks like. Okay, cool. So yeah. Now we want to dynamically change from the regular score to the final score when we've hit our time remaining equals 0. And that's not too hard to do. So let's go back to our code as always, and because it's always code executing here, we're able to do things like this. We're able to say, hey, we can just put this in an if statement. So if model.remaining seconds equals 0, then we want to do this for class. Else, we just want the class to be that. Okay, I think that should do it. And let's just maybe just highlight this. Oh, let's do the whole thing and just do a quick format just to tidy it up. The auto formatting tool is much better at getting the indentation right than I do, or at least consistent. Okay, let's compile that, and let's do a reload this page. Start. Okay, so the score is normal, and I've got 26 seconds. What defeats Fairy? Oh, Fairy is weak to steel. That's a well-known thing. Ghost. Best choice is Ghost. Fire. Don't. Let's see. I think Rock maybe. Poison. Ghost. Nope. Normal. Well, definitely want fighting there. Okay, there's our animation, and yeah, that was not horrible. It's not great. I am thinking about a lot of other things, like maybe I want a little rundown here of how many fights I had and how many winners, how many losers, and I can add that. But for now, that's a pretty good last step. So, anyways, thank you for joining me. It's been a lot of fun, and you know, I think I'll do one last thing, which is actually add something to copy this up to my personal website. So yeah, I don't need to document that, but I think I'll just, yeah, I'll leave it here for now. So thank you for your time. I hope you enjoyed this little exercise with Elm, and it's been a lot of fun. Take care. Thank you.